So when we talk about our different rocks, we're going to see that there's different behaviors that they might have. And the different behaviors that they could exhibit definitely depends on the temperature and pressure that the rocks are sitting at. This should kind of go without saying. If you think about it, if you have an object, any object, the hotter you make it, the easier it is to bend. Think about plastic, right? The hotter the plastic gets, the easier you can bend it. Rocks are the same way, right? The hotter they are, the easier they can bend, right? That's what we call elastic or plastic behavior, right? When they can bend, like you see here in this picture. However, when our rocks behave brittly, this is telling us they are very, very cold. So this tends to be what we find at the surface. Our plastic and elastic behavior tends to be what we find deeper down inside the earth once we are closer to the core. So let's talk about that heat for a few minutes, right? That heat inside of the earth can come up to the surface or move through the earth in several different ways. The first is called radiation, right? This is where we have electromagnetic waves transmitting heat into or out of a body, right? Or we can have conduction, right, which is where we have heat transferring, right, between two different objects because of a temperature difference. And you can see here in this picture, right, where the warm is going to go much more towards the cold, right? So we have a heating up due to this temperature difference. We can also have convection, which this one's going to be really important. This is what we're going to see inside of the earth, where our hot material, because it's hotter, it's less dense, so it rises upwards, and our colder material is much more dense, so it tends to sink. And this circular motion is what we call convection. We can also get advection, which is heat that's carried by the magma as it's coming to the surface, and as it flows out of cracks, right, it's going to release that heat. Now, we can actually, because of our behavior of our rocks, add two more layers, okay, onto the earth itself. So we know that we've already talked about the crust, the mantle, and the core. And remember, the crust is very thin, the mantle is pretty thick, and the core is pretty thin as well, but not as thin as the crust. Now, we can add two more layers, like I said. We can add the lithosphere, which the lithosphere is composed of the crust and the upper mantle. So the mantle itself can be divided up into two parts, right? The upper and the lower. So the crust and the upper mantle is what makes up the lithosphere. And what's important about this is that the lithosphere is rigid and solid, right? So it breaks into pieces, okay? It doesn't flow, it can break up into pieces. Now, below the lithosphere, so let's kind of go back here. So we've got our crust, our mantle, and our core, and we've divided up our mantle into the upper and lower part, and the upper part and the crust is what we call the lithosphere. Now, this lower mantle, okay, this lower mantle is what we call the asthenosphere. The asthenosphere is partially molten. It can flow. So that's pretty important there. Okay, it goes all the way down to about 700 kilometers below the surface. And what's really important here is this is where we get convection. I think we just talked about that hotter material is less dense and it moves upwards, and that colder material is more dense and moves downwards. That all happens in the asthenosphere. We're going to see that it's this interaction between the lithosphere and the asthenosphere that actually makes up the idea of plate tectonics. We're going to get into that in the next chapter. Now we can also have the mesosphere, which is the lowest part of the core. It goes all the way down to the core itself. It's really not involved in tectonic processes, but this area is very rigid. And it's very rigid, even though it's so hot, it's super rigid because it's under a lot of pressure, right? And that's what helps keep it solid. Now, the core itself is divided up into two parts. We have our outer core and our inner core. The outer core is pure liquid. This is the only layer inside the Earth that is purely liquid. And the inner core is solid. And again, the reason why it is solid is due to the pressure of the outside of the Earth, right, sitting on it, and that's what helps keep it solid. Now we're going to do a little side lecture about seismic, and we're going to see how we can tell that the outer core is liquid and the inner core is solid, because this is actually some pretty interesting information. And with that, that is the end of Chapter 2.